So in this video, we are going to learn how to find the largest domain or the domain of a given function. Now to find the domain of a function, then you simply want to find the values of x that will make the function defined. Now let's begin to solve some examples. How do we find the domain of a linear function? Say f of x is equal to 1 minus 2x. What are the possible values of x that will make the function defined? The domain of any linear function is the set of all real numbers from negative infinity to infinity. This means that whenever you insert any real number between negative infinity and infinity in place of x, then you are going to get a corresponding value for y or for f of x. This also means that the function exists for all real numbers, hence it is defined. So the domain for this particular function can be written as x is such that x is the set of all real numbers, because any value of x you plug in this equation is going to make the function defined. So now let's try some other examples. What is the domain of this function f of x is equal to x squared minus 5x plus 6. So like we did in the previous example, the domain for this particular function is going to be the set of all real numbers from negative infinity to infinity. This is because any real number you insert in place of x in this equation is going to make the function defined. So the domain is going to be x is such that x is the set of all real numbers. Likewise, if you have a polynomial, say f of x is equal to 2x cubed plus 9x squared plus 7x minus 6. The domain is going to be the set of all real numbers from negative infinity to infinity, so that we can write it as x is such that x is the set of all real numbers. So this is the idea. When there are no fractions or square roots but only polynomials, then the domain is going to be from negative infinity to infinity, which can be written as x is such that x is the set of all real numbers. Now how do we find the domain of a rational function? So let's say we have a function f of x is equal to x plus 5 divided by x minus 3. What value of x will make the denominator go to 0? To find the value of x that will make the denominator go to 0, we need to equate x minus 3 to 0. So it's going to be x minus 3 is equal to 0. And then we transpose negative 3 to the right hand side. So it's going to be x is equal to 3. So this means that the value of x that will make the denominator go to 0 is equal to 3, which means that the function is going to be undefined. So the domain for this function is going to be x is such that x is the set of all real numbers except x is equal to 3, because when you put x is equal to 3 in the function, it's going to make the denominator go to 0, which means that the function is going to be undefined. So now let's try this one. What is the domain of the function f of x is equal to 1 minus x squared divided by x squared plus 2x minus 8. Now as usual, because we have a rational function, then we need to equate the denominator to 0. So it's going to be x squared plus 2x minus 8 is equal to 0. So now we need to factorize this equation. The coefficient of the x squared term is 1, and then the coefficient of the constant is negative 8. So 1 times negative 8 is equal to negative 8. So we need to find the factors of negative 8 that add up to 2. So factors of negative 8 are negative 1 and 8, and then negative 2 and 4. Now we can add negative 2 and 4 to get plus 2 or positive 2. So it's going to be x squared minus 2x plus 4x minus 8 is equal to 0. Now, grouping like things, the greatest common factor between x squared and negative 2x is x. So x will be on the outside, and then we have x minus 2 inside the bracket plus 4 on the outside into bracket x minus 2 is equal to 0. So we have x plus 4 in a bracket and then x minus 2 in another bracket equal to 0. So x plus 4 is equal to 0, and then x is equal to negative 4, and then x minus 2 in a bracket, so it's equal to x is equal to 2. So this means that the values of x that will make the function undefined is x is equal to negative 4 and then x is equal to 2. So we can write the domain as x is such that x is the set of all real numbers except x is equal to negative 4 or 2. So now let's try to put negative 4 and 2 in this equation. So it's going to be negative 4 squared plus 2 into brackets negative 4 minus 8. Now negative 4 squared is equal to 16 minus 2 times negative 4 is negative 8 minus 8. Now 16 minus 8 minus 8 is equal to 0. So when we have the denominator to be 0, then the function is going to be undefined. Now let's try for 2. Now when we put 2 in this equation, then it's going to be 2 squared plus 2 into bracket 2 minus 8. 2 squared is equal to 4, and then 2 times 2 is equal to 4 minus 8. Now 4 plus 4 is 8, and 8 minus 8 is equal to 0. So the values of x that will make the function undefined is x is equal to negative 4 and x is equal to 2. Hence the domain is x is such that x is the set of all real numbers except x is equal to negative 4 and 2. Now, how do we find the domain of a function with a square root? So let's say we have a function f of x is equal to the square root of 2x minus 1. If the function has a square root or a radical with an even index, then we need to set what's inside to be greater or equal to 0. So it's going to be 2x minus 1 is greater or equal to 0. Now we are going to transpose negative 1 to the right hand side so that we have 2x is greater or equal to 1. We divide both sides of the equation by 2, and then we have x is greater or equal to 1 over 2. This means that for the function to be defined, then we need to have values greater or equal to 1 over 2. So let's confirm our answer by putting x is equal to 1 over 2 in this equation. So it's going to be 2 into brackets 1 over 2 minus 1, and then 2 times 1 over 2 is 1 minus 1 is equal to 0. The square root of 0 is equal to 0. Now let's say x is equal to 1 over 3, which is less than 1 over 2. So it's going to be 2 into brackets 1 over 3 minus 1. Now 2 times 1 over 3 is 2 over 3, and then 2 over 3 minus 1 is equal to negative 1 over 3. Since we cannot have the square root of a negative number, then it means that the values of x that will make the function defined is greater or equal to 1 over 2. So the domain can finally be written as x is such that x is the set of all real numbers, x is greater or equal to 1 over 2. Now there is an alternative approach to this problem. We had the function to be f of x to be equal to 2x minus 1. So we can set what's inside to less than 0 so that we have 2x minus 1 is less than 0. Now we transpose negative 1 to the right hand side, and then we have 2x is less than 1. We divide both sides of the equation by 2, and then we have x is less than 1 over 2. This means that any value of x lesser than 1 over 2 will make the function undefined. So the domain can be written as x is such that x is the set of all real numbers except x is less than 1 over 2. In this video, we are going to practice how to find the range of a given function. The range of a function is the possible set of all values of the dependent variable when values of the independent variable are substituted into the function. Or in other words, the range is the set of all output values of a function. So for instance, let's say we have a function y is equal to x squared, with x being 1, 2, and then 3. Then y is going to be 1, 4, and 9, because 1 squared is 1, 2 squared is 4, and then 3 squared is 9. In this case, y is called the output of the function, the range, or the dependent variable, because it depends on the values of x, and x is called the input to the function, or the independent variable. So now, how do we find the range of a function? Say f of x is equal to 1 minus 2x. To find the range of a function, we need to represent f of x with y. So f of x, which is equal to 1 minus 2x, is going to be y is equal to 1 minus 2x. Next is to make x the subject. So we need to transpose negative 2 to the left hand side and then y to the right hand side. So it's going to be 2x is equal to 1 minus y. And then we divide both sides of the equation by 2. And then we have x to be equal to 1 minus y over 2. Now 1 minus y over 2 is equal to 1 over 2 minus y over 2. We can factor out 1 over 2. So x is finally going to be 1 over 2 into brackets 1 minus y. Since any value of y will make the function defined, then we can say that y is such that y is the set of all real numbers, and this happens to be the range of the function. Let's take another example. How do we find the range of a function f of x is equal to x squared plus 1? Let's replace f of x with y. So y is going to be x squared plus 1. And then let's make x the subject. To make x the subject, we need to transpose 1 to the left hand side. So we are going to have y minus 1 to be equal to x squared. And because we want to do away with the exponent, we need to introduce square roots. So it's going to be the square root of y minus 1 is equal to the square root of x squared. Now the squared cancels the square root, and then we have x is equal to the square root of y minus 1. Now, what values of y will make the function defined? To find those values, we need to set what's inside the square root to less than 0. So we have y minus 1 is less than 0. Now we are going to transpose negative 1 to the right hand side so that we have y is less than 1. So the range is going to be y is such that y is the set of all real numbers except y is less than 1, which means that if we put any value less than 1 in place of y in this equation, we are going to get the function to be undefined. Let's try this one. Given a function f of x is equal to 5x divided by 2 minus x, how do we solve for the range? As usual, we are going to represent f of x with y and then make x the subject. So y is going to be 5x divided by 2 minus x. Now we are going to cross multiply. So we are going to have y into bracket 2 minus x to be equal to 5x. Y times 2 is 2y, and then y times x is xy, which is equal to 5x. Because we are interested in x, or because we want to make x stand alone, we are going to transpose negative xy to the right hand side. So it's going to be 2y is equal to 5x plus xy. Now, making x the subject, we are going to factorize. So it's going to be 2y is equal to x into bracket 5 plus y. And then we divide both sides of the equation by 5 plus y. So x is going to be 2y over 5 plus y. For this function to be defined, y must not be equal to negative 5. Hence, the denominator will go to 0, making the function undefined. So the range for this particular function is y is such that y is the set of all real numbers except y is equal to negative 5. What is the range of the function? H of x is equal to x minus 1 divided by 3 into brackets 2 plus x. Straight away, we need to represent h of x with y. So we are going to have y is equal to x minus 1 divided by 3 into brackets 2 plus x. Now we are going to cross multiply. So we are going to have 3y into brackets 2 plus x to be equal to x minus 1. 3y times 2 is 6y, and then 3y times x is 3xy, and then it's equal to x minus 1. Because we are interested in x, we would like to group x on one side. So we are going to transpose x to the left hand side and then 6y to the right hand side. So it's going to be 3xy minus x is equal to negative 1 minus 6y. So we are going to factor out x. So it's going to be x on the outside, and then we have 3y minus 1 inside the bracket to be equal to negative 1 minus 6y. We are going to divide both sides of the equation by 3y minus 1. And then we have x to be equal to negative 1 negative 6y divided by 3y minus 1. Now to find the range, we need to equate the denominator to 0. So it's going to be 3y minus 1 is equal to 0. And then we are going to transpose negative 1 to the right hand side. So we have 3y is equal to 1. We divide both sides of the equation by 3. And then we have y to be equal to 1 over 3. What this primarily means is that if we insert y to be equal to 1 over 3 into the equation, it's going to make the denominator go to 0, so that the whole function becomes undefined. So the range for the function is going to be y is such that y is the set of all real numbers except y is equal to 1 over 3. In this video, we are going to talk about one-to-one functions. We are going to learn how to prove whether a given function is one-to-one or not. A function is said to be one-to-one if different elements in the domain have distinct values in the codomain. Let's consider these two diagrams. For diagram A, we realize that 10 maps to 1, 20 maps to 2, and then 30 maps to 3. However, for diagram B, it is clear that 10 and 30 maps to 3, and then 20 maps to 1. Since we have elements in the domain corresponding to distinct values in the codomain for diagram A, it makes the function one-to-one. So diagram A is one-to-one, while diagram B is not one-to-one. This can be expressed mathematically as f of A is equal to f of B, where A is equal to B. So let's solve some examples. how do we prove that the function f of x, which is equal to 1 over x plus 2, where x is not equal to 2, is 1 to 1? Now, to solve this problem, we need to equate f of a to f of b. Now, f of a means that wherever you see x in f of x, we replace it with a. And for f of b, wherever we see x, we replace it with b. So for f of a, it's going to be 1 over a plus 2. And then f of b is 1 over b plus 2. So f of a is equal to f of b is going to be 1 over a plus 2 is equal to 1 over b plus 2. Now let's cross multiply. So we are going to have 1 into bracket b plus 2 is equal to 1 into bracket a plus 2. Now 1 times b is b, and then 1 times 2 is 2. 1 times a is a, and then 1 times 2 is 2. So we have b plus 2 is equal to a plus 2. So we can transpose these two to the right hand side. So it's going to be b is equal to a plus 2 minus 2. And then a plus 2 minus 2 is equal to 0. So it's going to be a is equal to b. Now, since a is equal to b, it follows that the function is 1 to 1. Let's solve another example. So if you have a function, say f of x is equal to 1 over x squared plus 3. How do we solve it? Is this function 1 to 1 or not? Straight away, we need to equate f of a to f of b. Now f of a is going to be 1 over a squared plus 3. And then f of b is 1 over b squared plus 3. Let's cross multiply. We are going to have b squared plus 3 is equal to a squared plus 3 after we cross multiply. Because we have 3 and then 3 here, we can cancel out the 3. And then we have b squared is equal to a squared. To do away with the exponent, we need to introduce square roots. So we are going to have the square root of b squared to be equal to the square root of a squared. The square root of b squared, which is equal to the square root of a squared, is the same as having square root of a squared is equal to square root of b squared. The squared cancel the square root, and then we have a is equal to the square root of b squared, which is equal to plus or minus b. Now what this primarily means is that at some point in time, a is equal to b, and another point in time, a is equal to negative b. So since a is not equal to b at all times, the function is not 1 to 1. Let's solve this. How do we prove that the function f of x is equal to x squared minus 9 divided by x squared, where x is greater than 0, is 1 to 1? So we know that f of a is equal to f of b. And then f of a is a squared minus 9 divided by a squared, which is equal to b squared minus 9 divided by b squared. So we cross multiply. Now we are going to have a squared into bracket b squared minus 9, which is equal to b squared into bracket a squared minus 9. So we multiply across. A squared times b squared is a squared b squared minus 9 times a squared is 9a squared. B squared times a squared is a squared b squared, and then 9 times b squared is 9b squared. A squared b squared cancels a squared b squared, and then we have negative 9a squared is equal to negative 9b squared. We can divide both sides of the equation by negative 9, and then we have a squared is equal to b squared. To do away with the exponent, we introduce square root. So it's going to be a is equal to, or the square root of a squared is equal to the square root of b squared, and then a is going to be plus or minus b. So we are going to have a to be equal to b and a to be equal to negative b. Now, because x was greater than 0, it means that we are dealing with positive numbers. So this, we are not going to consider this. So we are only going to consider a is equal to b because we require positive numbers. So since a is equal to b, then the function is 1 to 1. Let's try this together. Let's say if we have a function f of x is equal to x minus 2 divided by x plus 1. Is this function 1 to 1 or not? Let's see. So f of a is equal to f of b, and then we have a minus 2 divided by a plus 1 is equal to b minus 2 divided by b plus 1. Now let's cross multiply. So we are going to have a minus 2 times b plus 1, which is equal to a plus 1 times b minus 2. Now a times b is ab, and then negative 2 times b is negative 2b. A times 1 is a, and then negative 2 times 1 is negative 2. A times b is ab, and then a times negative 2 is negative 2a. 1 times b is b, and then 1 times negative 2 is negative 2. Now we have ab here, we have ab here, we have negative 2 here, and then negative 2. So we cancel them out, and then we have negative 2b plus a, and then negative 2a plus b. So we had negative 2b plus a to be equal to negative 2a plus b. So we can group like things. We will transpose a to the right hand side and then b to the left hand side, so that we have negative 2b minus b is equal to negative 2a minus a. Negative 2b minus b is negative 3b, and then it's equal to negative 2a minus a is negative 3a. We divide both sides of the equation by negative 3, and then we have b to be equal to a, or in other words, a is equal to b. And then since we have a is equal to b, the function is 1 to 1. In the previous lecture, we learned how to prove whether a given function is 1 to 1 or not. However, in this video, we are going to discuss how to find the inverse of a function. We learned earlier that a function f is 1 to 1 if an element in the domain maps to or corresponds to a distinct value in the range. The inverse of the function f is then the function that maps the distinct value in the range back to the value in the domain. So for instance, it is clear that the function f maps a, which is in the domain, to a distinct value b in the range. Now, the function that maps b back to a is called the inverse function, and it is written as f exponent -1. Notice that the domain of an inverse function is the range of the original function. And given a function, say f, whose inverse is f exponent -1, then the inverse of this function gives the original function f. Now let's move ahead and solve some examples regarding the inverse function or the inverse of a function. So let's say we have a function f of x, which is equal to 1 plus 2x divided by x, where x is not equal to 0. How do we find the inverse of this function? To find the inverse of the function f of x, we first need to replace f of x with y. So f of x, which is equal to 1 plus 2x divided by x, becomes y is equal to 1 plus 2x divided by x. Next, we interchange the positions of y and then x and make y the subject. So it's going to be x is equal to 1 plus 2y divided by y. Then we cross multiply. So x times y is xy, which is equal to 1 plus 2y. So we had xy is equal to 1 plus 2y. Because we want to make y stand alone, or in other words, we want to make y the subject, we need to transpose 2y to the left hand side. So it's going to be xy minus 2y is equal to 1. And then we factor out y. So we have y on the outside, and then x minus 2 inside the bracket, which is equal to 1. And then we divide both sides of the equation by x minus 2. And then we have y to be equal to 1 over x minus 2. So y, which is equal to 1 over x minus 2, becomes the inverse of the function f of x. Now, to confirm that the inverse of f inverse of x, which is equal to 1 over x minus 2, is f of x, we need to replace f inverse of x with y. So we are going to have y to be equal to 1 over x minus 2. Using the same procedure, we are going to interchange the values of y and then x and make y the subject. So we are going to have x is equal to 1 over y minus 2, and then we cross multiply. So we have x into brackets y minus 2 is equal to 1. So we distribute x across. So x times y is xy, and then x times -2 is -2x, which is equal to 1. Because we want to make y stand alone, we transpose -2x to the right hand side. So we have xy is equal to 1 plus 2x, and then we divide both sides of the equation by x, and then we have y to be equal to 1 plus 2x divided by x, which is f of x. So it is true that if you have a function, say f of x, whose inverse is f exponent -1 of x, then the inverse of this function gives the original function f of x. Now let's solve some more examples. Let's say we have a function f of x is equal to x plus 5 divided by x minus 3, where x is not equal to 3. How do we find the inverse of this particular function? So straight away, let's replace f of x with y. So y is equal to x plus 5 divided by x minus 3. And then we interchange the variables y and then x, so that we have x is equal to y plus 5 divided by y minus 3. And then we cross multiply. So we are going to have x into brackets y minus 3 is equal to y plus 5. X times y is xy, and then x times -3 is -3x, and then it's equal to y plus 5. Because we want to make y stand alone, we can transpose y to the left hand side and then negative 3x to the right hand side. So we are going to have xy minus y is equal to 5 plus 3x. We factor out y and then we have y on the outside and x minus 1 inside the brackets is equal to 5 plus 3x. And then we divide both sides of the equation by x minus 1. And then we have y to be equal to 5 plus 3x divided by x minus 1. Now this same y is equal to the f inverse of x, which is equal to 5 plus 3x divided by x minus 1. Let's take another example. What is the inverse of the function h of x is equal to x squared minus 1? To find the inverse of this function, we know that we are supposed to equate y to the function. So we have y is equal to x squared minus 1. Now the next step is to interchange the variables x and y. So we are going to have x is equal to y squared minus 1. Because we want to make y stand alone, we are going to transpose negative 1 to the left hand side. So we are going to have x plus 1 is equal to y squared. To do away with the exponents, we need to introduce square roots. So we are going to have the square root of y squared and then the square root of x plus 1. Now the squared cancels the square root and then we have the square root of x plus 1 is equal to y, which is equal to h inverse of x. Let's try this together. How do we find the inverse of the function f of x is equal to x squared minus 4 divided by 3? We need to replace f of x with y. So we have y is equal to x squared minus 4 divided by 3. Now we need to interchange the variables x and y. So we are going to have x is equal to y squared minus 4 divided by 3, and then we cross multiply. So we are going to have 3x is equal to y squared minus 4. Now we can transpose negative 4 to the left hand side so that we have 3x plus 4 is equal to y squared. And then we introduce the square roots and then we can do away with the exponents. So finally y is equal to the square root of 3x plus 4, and then y is equal to the inverse of f of x. Let's solve the last example for this video. Given a function g of x which is equal to 2x divided by 1 plus x, where x is not equal to negative 1. Let's find its inverse. Now we know that y is going to be 2x divided by 1 plus x. Now we interchange the variables x and y. So we have x is equal to 2y divided by 1 plus y. And then we cross multiply. So we have x into brackets 1 plus y is equal to 2y. And then we distribute x across. So x times 1 is x. And then x times y is xy, which is equal to 2y. Because we want to make y the subject, we will transpose xy to the right hand side. So we are going to have x is equal to 2y minus xy. And then we factor out y, and then we have 2 minus x. And then we divide both sides of the equation by 2 minus x. And then we have y is equal to x divided by 2 minus x. And y is also the inverse of g of x, which is equal to x divided by 2 minus x. So in this video, we are going to talk about composite functions. A composite function is generally a function that is written inside another function. So let's say we have a function f of x, which is equal to 2x squared plus 1. And then g of x which is equal to x plus 1. How do we find f of g? F of g is a composite function, which simply means g is inside of f and is equivalent to f into brackets g of x. To find f of g of x, we simply need to replace g of x with x plus 1. So it's going to be f into bracket x plus 1. Since x plus 1 is inside f, we are going to replace x with x plus 1. So it's going to be 2 into bracket x plus 1 all squared plus 1. X plus 1 all squared is equal to x plus 1 x plus 1. Now x times x is x squared. X times 1 is x. 1 times x is x. And then 1 times 1 is 1. We have x squared plus x is 2x plus 1 plus 1. So we are going to distribute the 2 across. Now 2 times x squared is 2x squared. 2 times 2x is 4x. And then 2 times 1 is 2 plus 1 is 3. So we have f of g to be equal to 2x squared plus 4x plus 3. Notice that f of g is not equal to f dot j, which is equal to f times j. Now f dot j is equal to f is 2x squared plus 1, and then j is x plus 1. Now let's multiply. We have 2x squared times x is 2x cubed, and then 2x squared times 1 is 2x squared. 1 times x is x, and then 1 times 1 is 1. So f dot g is equal to 2x cubed plus 2x squared plus x plus 1, which is not equal to f of g. Let's solve some more examples. Given a function f of x, which is equal to 1 minus 4x squared, and g of x, which is equal to 1 minus x. Let's find g of f. So this time f is inside of g, so it's equivalent to g into bracket f of x. So we are going to replace f of x with 1 minus 4x squared. So it's going to be j into brackets 1 minus 4x squared. Now, because we have 1 minus 4x squared inside g, then we are going to replace x with 1 minus 4x squared. So it's going to be 1 minus 4x squared. Negative 1 times 1 is negative 1, and then negative 1 times negative 4x squared is plus 4x squared. 1 minus 1 is 0, so g of f is 4x squared. Given a function f of x is equal to 2x and g of x is equal to x squared plus 4, how do we find f of g of 2? Now let's first find g of 2. G of 2 is equal to 2 squared plus 4. 2 squared is equal to 4 plus 4 is equal to 8. So g of 2 is equal to 8. So now this has been reduced to f of 8. So to find f of 8, we simply need to replace x with 8. So f of 8 is going to be 2 into bracket 8, and then 2 times 8 is 16. So f of g of 2 is equal to 16. Let's try this together. Given a function f of x is equal to x squared minus 1, and then g of x is equal to 3x plus 2. Let's find f of g. and then g of f. So to find f of g is simply f into bracket g of x. Now g of x is equal to 3x plus 2. So we have 3x plus 2. Now we are going to replace x with 3x plus 2. So we have 3x plus 2 squared minus 1. Now 3x plus 2 all squared is equal to 3x plus 2 minus 1. 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. And then 2 times 2 is 4 minus 1. So we have 9x squared plus 6x plus 6x is 12x. And then 4 minus 1 is 3. So this is f of g. Now let's find g of f. G of f is equal to g into bracket f of x, and then is equal to f of x is x squared minus 1, and then g is 3x plus 2. So we have 3 into bracket x squared minus 1 plus 2. Now 3 times x squared is 3x squared, and then 3 times negative 1 is negative 3 plus 2, which is equal to 3x squared minus 1. So it is clear that f of g is not equal to g of f, which means that f of g and g of f are not commutative. So that's it for today's video. If you like the content of this video, feel free to like, comment and share among friends. Don't forget to subscribe to receive more interesting videos. Hope to see you in my next video. Bye bye.